Again, good morning, everyone. Appreciate you coming out today to our lakes management presentation. Just a couple quick things. Today's presentation is being audio and video recorded. We will have a question and answer session. If you have any questions specific to Big Bass Lake that might not be for Fred or Mike regarding when we're going to fix the potholes on Big Bass Lake or anything like that, just wait until after the presentation and I'll be available to field all those types of questions. So I just want to quickly introduce Mike Harshorn and Dr. Fred Lubno from Princeton Hydro. They're going to give you a presentation today on our lake management plan. They've been with, Princeton Hydro's been with Big Bass Lake since 1994. They're well respected in the industry. They're great to work with. So I'm sure they'll be able to answer all your questions about our lakes and our lake management plan. So with that, I'll turn it over to Mike.
Thanks, Dave. Good morning, everyone. Thanks for coming out on Saturday morning. Like Dave said, Fred and I have worked with Big Bass Lakes. Well, I've been with Fred since 2006, and Fred's worked at the community since the early 90s. So quite a bit of history and historical knowledge of how the lakes have functioned over time and how they've changed. We're here today to discuss the Big Bass Lakes, the 2020 updated lakes management plan. So the objective of this plan is first off to build upon the original plan that was conducted in '94 by Fred. So a comprehensive watershed plan and a lake plan. These plans have been periodically updated approximately every 10 years due to changing land use conditions, climate conditions, things like no invasive species, algal blooms, changes in the fishery. So they've been routinely updated, and that's been something that we have to give kudos to the community for. So recognizing that the lakes are not in a consistent state. They change over time, and as such, management has to adapt to that as well. The scope of work for this plan, and we really want to go over this plan today, but certainly welcome and want to hear any questions you may have and address any concerns that we may not have addressed in the plan. That's really the overarching goal for the plan. So we analyzed the long-term water quality database. We have water quality data that goes back to 1993, I believe. Within the plan, you'll see we typically focus on the most recent 10 years, so from 2010 up through 2019. Updated watershed site assessments. We met with Dave and with some community members to discuss areas of concern in the watershed, areas of stormwater problems, erosion, nutrient and sediment transport to the lakes. These are concerning more long-term corrective measures that will ensure the health of the lakes for decades to come. We had 2 field visits by some more scientists and stormwater engineers where we physically walked watersheds, further documented areas of concern, and all that data was geo-referenced with GPS and utilized to develop recommended what are called BMPs. Does anyone know what a BMP is in the room? Lots of jargon, so let's define that. That's going to be important. It's a catch-all phrase for best management practices. So in the realm of watershed management, what we're really looking towards is areas where stormwater is transferring quickly, swiftly, transferring sediment into your lake that's going to fill in the lake. And attached with that sediment is phosphorus, which is really the nutrient that's going to spur algal growth. So from like a long-term management and restoration perspective, we need to make sure that we're cognizant that the lakes aren't discrete units, the parts of their watersheds, their ecosystems. So what's going on in the watershed is going to impact the lake ultimately. And your community's been doing a great job over the past decades, recognizing that and taking really proactive measures. We developed kind of new component for these 2020 management plans, what we call beach mini plans. Really focused with another jargon term, harmful algal blooms. Anyone heard of that? Not surprisingly, many folks have. So they're increasing in prevalence regionally. So not just in your community, which we experienced to some degree in Big Bass in September, but we had major issues in Pacom, some of the larger lakes in New Jersey and Pennsylvania as well, and also throughout the country. And then finally, just the updated overall management plan. So to include the watershed site assessments, some generalized watershed recommendations, and some general in-lake management recommendations that weren't necessarily discussed in the nearshore beach meeting. So quickly, we'll run through this, just a little bit of data. Lake sampling, we're up here 4 times during the growing season, which is May through September. You may recognize this fellow, that's Fred, sitting right here.
That's great.
Yeah, get a little further, you get a good sample. So we collect temperature, dissolved oxygen, conductance, pH, with a meter in the lake, so real time. So we're interested in, are your lakes thermally stratifying? Or is your oxygen dropping out, which is, negative for the fishery? What are your algal types in abundance? Do you have a lot of green or diatom type algae that are considered, quote, good algae? Or do you have the cyanobacteria, which are the blue-green algae, that typically are reflective of potential water issues? We're measuring the nutrients that fuel that algae, so phosphorus and nitrogen, chlorophyll A. And doing this annually, developing a long-term database, we kind of detect changes over time and help to parse things out. So are we seeing changes in water quality due to management efforts? Are we seeing improvements? How are lakes reflective of change in weather conditions? It's all important. Big Bass Lake, you can see we have some historical, it's called TP, that's phosphorus, that fuels the algal bloom. This red line here is kind of threshold boundary. You'll see year to year, depending on the weather, can certainly change. Overall, your phosphorus concentrations are okay, but we're still seeing potentially some issues with cyanobacteria, and we'll discuss why that is shortly. Second, so that's the transparency of the water, which is influenced by algal densities. This 1.0 meter, about 3.3 feet, that's a threshold value. You're typically above that, on average. But at times, especially later in the season, sometimes you get inch up closer to that 1 meter. Larson Lake, we typically see low phosphorus values here. And you see that at Larson and Natalie, and that's because of how they function and their flushing rates compared to Big Bass Lake. When you think of Larson Lake and Lake Natalie, the watersheds are huge compared to Big Bass Lake. That means there's a lot more land that drains through them. It means the water flushes through much more quickly. It means there's less time for algae to take up those nutrients and to grow and proliferate. See again, Natalie, the nutrient levels are particularly low as well. Here's some long-term chlorophyll A data. Chlorophyll A is just the pigment that algae have. So if you know how much chlorophyll A you have a decent estimation of how much algae you have. This 20 line is a threshold. And you can see here Larson and Natalie rarely ever gets anywhere near that line. Predominantly a plant-dominated system. So a lot of the growth in the lake is just the submerged plants, as opposed to the algae. Big Bass Lake is variable. We see here at times in 2011 where we exceeded that threshold. And again in 2018, and I know 2019 did in September. We don't have data for that, but we're going to maybe increase our sampling frequency. So we have kind of a better estimation of what's going on throughout the summer. Now, some lakes, how the near lakes don't compare to some regional lakes. So we got up to say maybe 24 here. I mean, Fred and I work with plenty of lakes that get up to 80 or 90, 100 plus. So you certainly have some instances where you have some higher than usual algal growth, but comparatively speaking, regionally, your lakes are in pretty good shape. Some of the primary issues facing each lake, again, big bass, under certain weather conditions, like we saw this year, where we had a lot of rain early on in the spring, flushes a lot of those nutrients into the lake, has time to sit and proliferate in August and September when we were in drought conditions. We have increased sediment through it. We have invasive plant species in all three lakes. Primarily the worst and Larson Lake. We have a lot of fanwort and parrot feather, both of which are kind of escapees from the aquarium industry, unfortunately, and difficult to manage and control. And then thinking of these lakes again in the context of the watershed, long-term, addressing stormwater issues and septic as you've done as a community. So quickly to launch into the watershed management portion, this is where we did our watershed walks and looked at potential areas that could be addressed. Again, met with the community, 2 site visits with our stormwater engineers and ecologists, and a recommendation of, again, that strange term, EMPs. And we'll show some examples of those as we go through these slides. So what are we looking at when we talk about stormwater? Why does it matter for your lakes? So stormwater is basically all these diffuse sources. The rain falls, it hits your roofs, it hits your driveways, it hits your septic mounds, and it carries dissolved nutrients and sediments in kind of diffuse nature to the lakes. So pick up pet waste, you can pick up fertilizers, you can pick up leaves, motor oils, detergents, trash. Ultimately, a lot of that can make its way to the streams and to the water courses. So we want to understand what's going on in the watershed to keep this transport as low as possible. And how do we do that? Well, we focus as a company on green infrastructure. So green infrastructure is stormwater management using nature as your template. Utilizing natural features such as rock formations and vegetation to slow down that stormwater, allow it to soak a little longer, infiltrate into the ground, and to take up those nutrients. That's as opposed to shunning as quickly as possible into a lake or to a stream, which is typically how stormwater is handled in the past. Typical types of green infrastructure, things like just vegetating, green barrels, green buildings, tree planter boxes, pervious concrete, or pervious paver type systems. Those were non-point sources. There's sources that are termed point sources, end of pipe. So if you think of the typical industrial polluters, a pipe coming out of the factory. We do have one single point source in the watershed. It's the Eagle plant in Big Bass Lake watershed. And I really have to give kudos to the community. You guys are really on top of that, and we work with them very closely in terms of reviewing their discharge monitoring reports, which are a regulatory restriction from the state of Pennsylvania. They measure their discharge of all sorts of parameters, including phosphorus, which is important to potential algal growth in Big Bass Lake. And Dave routinely shares that data with us, and we review it and we're in constant communication. If we ever see instances of perhaps we have extremely heavy rainstorm and perhaps they have a discharge higher than we should have, we have good communication with them to address that. So definitely very good community section. Your TEP discharge from the plant, it's all below their regulatory permit level in 2019. Here's just a figure of the watershed of Big Bass Lake. You see it's relatively small, it's about 1,000 acres. And we broke it down into sub-watersheds here. And we looked at the land use as well, so a lot of forest, residential, we have this commercial complex up here. We have some land use, and we don't have to get into this, but we did some land use comparisons, how it's changed in the past 10 years. It's conducted in the report. And why this is important, because changes in land use affect stormwater runoff, affects nutrient loading to the lakes. So as you move away from the green and more to the heavy sources of red, if not managed properly, it could cause increased nutrient pollution to the water bodies. Now this entity up here in the red, a pretty solid stormwater management. And typically seen the controls on your land, and it hasn't impacted the creek that we observed. Kind of a busy map here, but what I want you to take away from that is just the size of this watershed relative to Larson and Natalie, about 10,000 acres. So a lot more water moving through this area. Larson and Natalie, being the headwaters of the Lehigh River, function more as like a riverine system where the water moves through a lot more quickly. The land use again for these. So along with that desktop analysis, that kind of geospatial analysis, we walked the sites and looked for areas where we could improve stormwater management in the community. And you have a pretty well-vegetated forested community, so there's not a ton of opportunities, but we were able to find some examples to show you. Things like these drainage swales, and we did all this work in winter, so that's why you're seeing all the snow on the ground. So this work was conducted in October, November, December, January. A lot of these conduits here on the side of roads, frequently utilized to convey stormwater. There's some potential ways to improve those. Work called step-wheel conveyance systems. This was done in Maryland. And what you'll see is here on the left, just a kind of like a channel that just shunts the water as quickly as possible down the slope. What they're really looking to do here is just kind of mimic a stream system with these pools here and these berms to slow that water down. So when you get rain events, it slows down, the sediments drop out, and the vegetation takes up any nutrients. So pretty cool, pretty simple to implement. You can do those potentially on the side of some of your areas. Looking at Larson Lake, there's some areas of impervious area. Impervious area is simply things like blacktops or roofs, hard areas where rain hits and it runs off pretty quickly, as opposed to slowly soaking through the soil. So there's some certain areas where you could maybe work with directing the stormwater from the parking lots into like a vegetated, what's called a bioretention area here. So just a depression with native vegetation could be a cool educational centerpiece for the community, provide habitat for pollinators, bees, things that depend on them birds. So. And here's a simple graphic. We did this at Fawcett Park in East Amwell, New Jersey. Again, you're just trying to direct the water to a vegetated area where it can slowly infiltrate through the soils and feed the vegetation. Again, some impervious areas at the Administration of Public Works area with some stormwater infrastructure, grates and pipes and so forth. Potential option to utilize what's called a manufactured treatment device. This is just pumping the water in. There's a series of baffles. Sediments fall in, the nutrients fall out, and then clean water comes out the other end. And there's accessible manholes at the top that pump out those sediments and refluid and so forth. We looked at some sites that were on maybe nonprofit and municipal properties. The point for doing that is these type of entities are typically eligible for grant funding. So you could potentially partner with some of these folks here and develop some stormwater projects that would be beneficial for them and also for your watersheds and for your lakes. So we looked at the Goldsboro United Methodist Church. Again, parking lots, potential areas to slide back some of that pavement and put integrated vegetative slope buffers there. Areas that are currently like compacted gravel around the lakes for trailer and way access. Potential ways to modify those, things like vegetative pavers, maybe even porous pavement type materials, which just allow for a little less surface runoff and more infiltration. Residential source control on your own properties. You know, things like volume control, taking some of that runoff from the roof and storing it in a rain barrel or cistern and utilizing that to water your gardens. Small parts overall, but collectively can be, you know, big impact to the watersheds. Disconnection of those impervious areas. Not having the downspout go directly into a storm sewer. Directing that through some vegetation, perhaps into a planted garden area, allowing it to slow down and circulate. You know, lakeshore buffers, a lot of the lakes do have those buffers around them. I believe the Community Institute's like a 60-foot setback for building from waterways, which is great. But maintaining this vegetated area along the lakeshore, it's really important to help keep that lakeshore stabilized from wind and wave erosion. It slows down the transport of nutrients from upslope before it gets to the lake. And also, it's an important transition zone for the fishery and the bite of the lake. You have this upland interface going into kind of emerging areas where you may have cattails and things like that, extending into the water. A lot of those near-shore areas are really important for macrovertebrates, for juvenile fish. It's a very important nursery area. So we definitely advise homeowners to do this whenever they can. It doesn't mean you need to not access the shore. I mean, certainly provide yourself a way to get down there and enjoy the lake. You know, really important in your community, and a lot of communities in the Poconos as well as septic. And you guys are on top of this, especially with the ordinance, so hear this. Septic systems in this area, you typically have rocky soils, shallow depth of groundwater, shallow depth of bedrock in some areas. You have steep slopes. So all that means is it's more difficult for the waste to be treated by the soil column. So that's why it's important to pump these systems out. And we think of the systems that are most closely located near the lake as important. And they really are, but really it's all the systems in the watershed. So some like a general overview of our watershed management. There's more inclusive material in the report. Happy to take questions about that at the end. Kind of want to shift gears into the algal portion, the inlet stuff, things folks are most often concerned about. Harmful algal bloom management, lumped in with the beach plants, looking at preventative and responsive techniques. So harmful algal blooms in this area typically refer to the cyanobacteria, the blue-green algae. They've been around for a very, very, very long. They like three things. They like high temperatures, they like high phosphorus concentrations, and they like stable water columns. Of the things we can control, can't really influence the temperature of the water. We can control phosphorus concentrations in the lake, and we can modify to some degree the stability of the water column. And most of your lakes are shallow. They mix naturally just by wind action. So what we're really looking at is controlling phosphorus concentrations. Here's a German shepherd swimming in this green PC setup. When advised that dogs are particularly susceptible to algal toxins and so forth. Big instance in North Carolina this summer with a few dogs were in waters like this and drank them and succumbed to some poisoning and passed away, unfortunately. Common types of cyanobacteria, you have Dolichospermum, Microcystis, and Phenazomina, three of the primary nuisance forming types that can produce cyanotoxins. For the prevention, management, and treatment, we kind of look at these as integrated components. Ideally, we want to prevent these blooms from forming, but we want to have plans in place to how to manage and treat those if they were to occur. Very unique group of organisms, cyanobacteria. They can photosynthesize, they can grow at different light intensities. They have resting spores called achenes that they can put in the sediments and use to grow from at a later point. Some can fix gaseous nitrogen. It's really cool ecological adaptation. So if you even have a lot of phosphorus but not much nitrogen, some can fix that nitrogen atmospherically. They can use enzymes to cleave phosphorus off organic compounds. So most algae, from an evolutionary perspective, utilize inorganic phosphate for growth and can't really utilize this organic form of phosphorus. Cyanobacteria can use both.
Yeah, I do want to just quickly chime in that those heterocysts, when you saw that chain, that one clear cell was a heterocyst. And that one clear cell right there, that's a heterocyst. And if you can fix your own nitrogen, that's great. But to do that, you need a lot of phosphorus. So as you see development in watershed or an increase in the phosphorus loading in freshwater systems, not only do you see more algae, you see more of the bad algae, the cyanobacteria. So if you're down in the Chesapeake Bay, you're concerned about phosphorus, but your main concern is nitrogen, because what really drives a lot of the growth of nuisance algae in marine or estuarine systems is nitrogen. In freshwater systems, it's really phosphorus that drives the growth of the nuisance cyanobacteria.
Yeah, that's a good point. So again, these gas vacuoles can also help these algae migrate through the water column. So all this means is they're really well adapted to present phosphorus. They're really well poised to grow in nuisance densities under certain conditions, high phosphorus, high temperatures. And we're seeing changing weather. The amount of heavy rain events in this region is increasing. I mean, we saw that this spring. You know, the amount of rain events were what, 3+ inches in a 24-hour period. The frequency of those events is increasing. So what that means is we're getting more rain sunning through the watershed, transporting pulses of nutrients to the lake. I think this is over 50 years. The source is provide that for you. Yeah, 50 years. Sure. Again, the sources for all these are down at the bottom if you would review them and provide the papers. Mean annual temperatures in the northeastern portion of the U.S. They vary year to year. On average, they're going up. We have a long-term data set at Lake Pacom in New Jersey where we monitor very consistently for the past, how many years, 30 years? Yeah. You know, same stations, same time of year. And we're just seeing, you know, on average, those surface water temperatures are going up. So the temperatures of the lakes are increasing. We're getting more heavy rain events. So the weather's not really working with us to preclude these events.
Yeah, I'd like to just make a couple points, because
Please
we were sort of in the thick of, so Lake Pacom is the largest lake in New Jersey, and they had huge, massive blooms this past year, and I can tell you, you were not alone. That regionally, Harvey's Lake, Lake Pacom, Lake Mohawk, some of the drinking water supplies we deal with up in New York, DeForest Lake, all these blooms in the larger, deeper lakes seem to hit around the same time. It was June. And it's because June was this month that we had these intense, like Mike mentioned, we had these intense large rainfalls. And then that would be followed by a couple days of sunny weather. That set up for these early season blooms. What we did see in some of the shallower, smaller lakes, especially up in the Poconos, are the blooms really didn't hit till the second half of the growing season. So a lot of, like in June, a lot of the lakes we've been monitoring in this region really didn't see a lot of issues with algae because of that flushing. But as soon as things sort of settled down a little, once we got into like July, August, and September, that's when we saw lakes in this region really suffer from those blooms. So, you know, temperature is a big part. Like mentioned, the stability of the water column, but nutrients. And that's why we focus so much on nutrient control, because that's what we can really get a handle on in terms of reducing that algae.
Yeah, thank you. This was a nearshore area, Big Bass Beach in September. So we saw these localized buildups of algae, and just under the conditions Fred described. So we had a lot of rain earlier in the year, and then in August and September we entered kind of drought conditions. Water came in, sat, stewed, and produced these blooms. So our goal, again, to minimize or avoid them, we developed within the plan have a methodology the community can use, residents can utilize, your administration can utilize to monitor the nearshore areas. Kind of like a simple flow diagram. Step one, go out and look. Does this look green? If not, okay, you probably don't have an issue. If so, what do I do next? And just walking through that progression. So, pretty wordy here, but again, it's just simplified progression. Is it green? Yes, go to the next step. No, stop. Simple. And ultimately, what we're looking at is water green. Is there going to be cyanobacteria? If so, how much? We kind of utilize a cell density threshold of 20,000 cells per mole. If it's above that level, more than likely having a balloon and be advisable to test for these cyanotoxins. Pennsylvania doesn't have a recreational threshold for this. New Jersey does. EPA has some draft thresholds that we referenced here. Microcystin is 8, cylinders for Mopsin is 15. There's some pretty low cost, relatively easy to employ tests that you can utilize even at the dock to determine this.
And I do want to mention that there are dozens of these compounds.
Yeah.
There's a wide variety of them. These are two that we have criteria for because number one, microcystin is the most common one. So if you're going to test for one compound, that's the one we would strongly recommend. Cylindrospermopsin is pretty rare, but EPA has a lot of data on that particular toxin, which is why there's a threshold criteria. They're working on some thresholds for other cyanotoxins, but those are the two that EPA currently has. And so Pennsylvania says, well, we will, any sort of recommendation we'll do, we will use EPA's, but of the two, microcystin is the most common toxin. So if you're going to monitor one, that's the one you're going to monitor
So going back to kind of like some of the preventative techniques, kind of methods to soak up nutrients so those cyanobacteria can utilize them to proliferate. There's a few different types of technologies we can look to utilize, and our company is actually evaluating several emerging technologies with the state of New Jersey hopefully this year, and we'll be able to kind of report back on the efficacy of those, and may find that some of them are able to be utilized in your lakes as well. Things like nano bubble aeration, ultrasonic units that look to disperse or break down algae. We have experience utilizing these in floating wetland islands. The whole concept is we have some recycled plastic material that serves as a substrate for growth of wetland plants. Plants grow up top, the roots grow down into the water, and there's a biofilm, a beneficial bacteria throughout this high surface area acreage. This biofilm is really the workhorse, so it's pulling up nutrients from the water column, utilizing them to grow, and preventing the algae from utilizing those nutrients. This is kind of what they look like being put together. So it's just plastic, there's plugs in here, you put things like cattail, iris, pickleweed, really showy, pretty vegetation. You can deploy these in your lakes, you keep them out through the winter, they'll die back and they'll grow again in the spring. These particular types were actually field tested in Montana, so they survive Montana winters. And when they really get going after a year or two, they can grow up quite tall. We have a lot of plant biomass. The big workhorse here is sucking nutrients up out of the lake. This is an example of a line. I think we installed at the Hideout community. And They've been in for about 10 years, and the lifespan of those when we originally installed them was estimated at 10 years. They're still doing great. So, dropping the lifespan estimates for those maybe 15 years. So, how many nutrients can we pull up? The 250 square foot island annually can remove maybe 10 pounds of phosphorus. And if you think a pound of phosphorus can make like 1,000 pounds of wet algae, they can really help supplement some of the other management activities you're doing. There's no silver bullet, but one tool to work with. Phosphorus inactivation, there's particularly for big bass lake, there's products you can apply to strip the water column of phosphorus, products such as Phoslock that will bind with this inorganic P in the water column, inactivate it and sink to the bottom. There's Phoslock, there's other aluminum-based compounds, they each have their pros and cons, different costs as well. But there are things that we're potentially looking at recommending in the future. So we would typically apply this, or you can have someone apply it. You want to do that in late spring. So after the pulse of nutrients has come into the lake, but before the stable top conditions set up, before it blooms, you strip the lakes of phosphorus. Physical exclusion is a good means in the nearshore areas. So on the left, it just shows a real close-up of what's a bubble curtain. It's an aeration unit with diffusers on the bottom, similar to like a fish tank. So we installed one of these at the Big Bass Beach, and the idea is the Big Bass, where you have the prevailing winds pushing all the stuff towards that beach, this bubble wall would kind of serve as a physical barrier to give you some improved water quality conditions in swimming areas. And then finally, more of a reactionary measure, there's algicides. Many lake communities use copper-based algicides. They're low cost. They work really well, but some algae can develop resistance to those types over time. The coppers can go up in the sediments. If you're putting copper down for decades after decades after decades, you get a buildup of copper in sediments. And finally, some type of fish are susceptible to copper more so than others, especially the carp. Things like koi and trout, which you don't have in the lakes, but those species are particularly susceptible to copper. Green Clean Throw and similar types are peroxide based, so they're strong oxidizers, so they'll break down algae relatively quickly. Depending on the type of algae you have, some can selectively treat the bad types of algae or the beneficial ones like the diatoms. And there's some literature that says some of the peroxide-based algicides can actually oxidize those cyanotoxic compounds. And then finally, some quick overall lake management, and then we'll field any questions you have. So again, algal blooms in Big Bass Lake and Larson Natalie, if they were to have them, they typically don't. We're looking primarily at nutrient uptake, whether that's addition of nutrient activation products, maybe floating wetland islands at inlet areas or beach areas, selective aeration in nearshore areas. I already did this at Big Bass Beach. And then reactionary, pretty much looking at algicides. So that's why we focus so heavily on prevention. I want to touch quickly on just some overall in-lake management updates. Dredging, I believe you were originally set to do some spot dredging in 2019. There was some outlet fixes that needed to be conducted, so kudos to you guys for taking safety first and fixing those regulated features. So spot dredging may be occurring in the future, 2027, somewhere around there. The community has quite a war chest for that effort, so again, kudos for long-term planning and administration. Princeton Hydro did what's called a bathymetric assessment looking at sediment depths in 2014, and there's certainly areas that could benefit from dredging. Dredging is not necessarily going to prevent any future algal blooms, but It will increase access. It will remove sediments that plants utilize as a substrate for grading. And this was a figure here that was developed in 2014, a big vast lake. And it was subsequently sectioned off into sections. We had A, about this line up, B, the central point, C. A lot of sediment down here. We do have pretty high water depths here, so there's not really much in the way of impediments to access. So if you were to think of spot dredging, and you're certainly in a position to do so, perhaps you may want to focus up here if it's impeding folks boating and so forth. The sterile grass carp have been a really cool addition to your herbicide program to get a hand on aquatic plants. So these guys are a sterilized form of carp, meaning they don't reproduce, but they're sterilized. They have an average lifespan of about 10 years. And like humans, when they're young and they're kids, they eat a lot and they grow pretty quickly. And then as they get older, they kind of slow down. So you do need to periodically restock them. The community's been on top of that, doing plant surveys annually, multiple times a year, and filing for restocking permits. And really utilizing these as a primary source of plant control so you can rely less on the utilization of herbicides. Now, like some carp, they can be pigs on the water, but they do tend to like some plants over others. They really like the soft, fleshy tissue plants. Fanwort, one of your big invasives, moderate to high control for that type. Parafeather, lower to moderate control. And that's because that has kind of, especially the vegetation of parafeather that grows out of the water, you'll see it's like bright neon green, pretty waxy. Just not as palatable to these fish. If they had nothing to eat, they would devour it. But they're going to eat the other stuff that they like first. Some historical stocking data here and some projected stocking dates in the future. A really cool thing that the state has implemented now is they don't give you a one-off permit that you have to use in 1 year. Expanded over a period of 3 years so you can stock conservatively, assess, see how the fish are doing, and then stock more if you need to. What you don't want to do is stock heavy, have them eradicate all the vegetation, and then what happens? Then you just get algae growth. And then your fishery could suffer as well. You guys have all been on top of that, so again, good job. And then finally, aquatic herbicides. Still important to keep in your tool belt here. There's two different types, broadly speaking. Contact herbicides sprayed on the plant, obviously in the water. They burn the tissue, they break the tissue up. Systemic herbicides, they're more expensive, certainly more expensive. They provide longer-term control. They kill the plant more slowly, so you're not seeing a big pulse of nutrients come up by eradicating a lot of plant biomass in a short period of time. So that slow die-off is going to result in reduced kind of pulse of nutrients. So potentially, if you were to kill off a lot of plants with contact herbicide in August, and then you have a sustained period of hot weather, could make algal growth worse. Your community understands this and doesn't really do that, but some communities do. Yeah. So senescence means to die back of the plant. Good question. Correct. Yeah, correct. So the contact is going to just basically kill the plant quicker. A systemic herbicide is going to kill the plant slowly, over about 30 to 60 days. So you have kind of like a slow die-off, a slow decomposition. Exactly. Correct. Yep. Yeah, good question. And that wraps it up. So we'd love to hear your questions. Fred and I are both available. Thank you for coming out.
And his team, Katie and Clay, and some other people that were out, they did all the work, even though my name is on this. I provided some advice and some guidance, but they did all the work, so kudos to them.
Yes,
I have a series of questions, actually.
cool.
One of the slide you had up about dredging. Oh, sorry. So the slide you had up about dredging, you skipped over fairly quickly. I did see a line in there that said dredging will help solve the algae problem. So what is the benefits of spot dredging when it seems that the algae bloom seems to be our biggest issue at the current time?
Oh, yeah, well, so there's a couple things going on. One is dredging will help in terms of if you make the water depth deeper in those areas, there's less sunlight hitting down there, so that means less plant growth and less benthic algae growth. The other benefit to dredging is you're creating more aquatic habitat, and it helps with access for boating. You're right, for the blooms you're getting, dredging will help minorly in that as you make those sections deeper, less sunlight, you get less of the benthic growth. But for the algae, you're right, you do need to focus on the nutrients. So there are two components within the same plan that need to be addressed. Maybe one is more immediate and one is more long-term.
Thank you. Now, the floating islands, like you said, they're 15 by 10, the pictures that you've shown of the floating islands. How many would you recommend for Big Bass Lake?
Yeah, I mean, you can certainly, I wouldn't recommend them again as like a silver bullet type thing.
No, I understand each item is a strand that would help, like the septic policy, then the floating islands, and then your other recommendations.
Right.
So,
You could implement those, potentially where Tamarack Creek is emptying out into the lake. They would help take up some of those nutrients and settle out some of those solids. But also maybe the beach areas as well.
Initially so we started working with the islands in 2010, and back then they were sort of used the way a wetland BMP would be used. So the whole original concept was one of those 250 square foot islands would be good for anywhere between 2 to 10 acres of surface water. What we have found is that the number of islands installed isn't as important as where you strategically place them. So like Mike mentioned, putting them up near the inlet where the wastewater discharge is coming from, that would be really key because you would want that to serve as that buffer. So any sort of elevated phosphorus that's coming through, even if it's temporary, is intercepted by that island. That's what we have found, number one. And number two, we tend to put them close to the shoreline, maybe say a swale or a stormwater pipe, so they're getting the higher phosphorus. But also we've learned over the years how to keep them anchored and tethered, because like Hideout, we haven't had problems with them, but Harvey's Lake, we have about 5 of these large islands, and almost every year at least one of them breaks away. And we get the call. Matter of fact, I was up at the council meeting this week, and one broke away, and it's frozen in the ice, so when we hit spring, we got to move it. So depending on your wind activity and the size of the water body, like a Hideout, we rarely have an island break away. But so we've learned over the years how to anchor them and tether them, and really logistically place them where higher nutrients are.
I just have 2 more that I'll give up the microphone. You did mention, Fred, I believe, selective aeration. Now, is that a system like we installed at the Big Bass Beach and put it elsewhere in the lake?
Yeah. So, and Mike mentioned this, you're a shallow water body, so you're well mixed. In the past, when you had a lot of plants, this is back like in the 90s, when the fanwort was really starting to take off, we actually saw that there was so much weed growth that you had no oxygen at the bottom because those plants were preventing the circulation. We don't see that now, we see well oxygenation. So you don't need whole lake oxygenation, but selective oxygenation along a beach. And it's not necessarily for water quality, but it's to prevent the accumulation of the algal cells. Because it's like once you get a certain concentration of algal cells, that's when the cyanotoxins could get to a level that would negatively impact pets, or people may have allergic reactions.
Now, I didn't see in your lake management plan recommendations of where to place that. Will you provide those for us?
Yeah, I mean, I know specifically for Big Bass, the focus is the beach area.
Right, which we have the aeration system.
Yeah, and there was inclusion of maybe evaluating that in Larson. I mean, again, like, Big Bass has primarily assigned bacteria, so I wouldn't say it's necessarily needed at Larson at this time, but that would be a place that they could be
I
considered.
mean, and it's the beach areas we're focused on. for two reasons. Number one, that's where people have the direct contact with the water. So if you, and you see this in a lot of lakes, you could be in the middle of the lake and go, wow, the water looks great here. And then when you go to the shoreline, especially in a beach area where the wind is concentrating all the cells, it's like, oh, it's horrible here. So it's those areas we look for circulation just to prevent that accumulation.
And the grants that you mentioned, they would work with charitable institutions that are in the watershed, such as the Methodist Church or the fire company?
It's possible. I mean, so we're looking at all sorts of potential sources of funding. You can potentially team with a conservation district, municipality, but then some of the nonprofits, if they're a 501c3, they're eligible for that type of work.
So that, do you guys do that, or do we have to write the grants?
We very frequently, as a matter of fact, we've done that in the past when we've gotten a small, we've grown greener grant for some stabilization issues well over 10 years ago, but we've done that in the past.
Okay.
Yeah, the planting at Larson Lake was under a grant program. You know, typically the nonprofits are eligible, but it really depends on the specific grant that's being released.
Thank you.
Right, so Mike, if I could just clarify on the aeration. So you're not recommending any additional aeration at Big Bass Lake, but potentially at the larger beach areas where you would recommend an aerator if we were to do additional aeration? Is that
Yeah, correct. I mean, the water quality data that we've collected hasn't shown any no oxygen areas. And that's primarily when you would want to say, okay, the data supports the installation of an aeration. Recently, we haven't seen the data support that. So, yeah.
My question is, who owns the water in our lakes?
Technically, the water is owned by the Commonwealth of Pennsylvania, the water. Now, the land underneath may or may not be owned by private property owners. That really depends on, the existing survey and deeds, but the water is owned by the Commonwealth of Pennsylvania.
And do they have any responsibility for the lake management?
They do, and that's why they offer grants and why they provide incentives for people to clean water up. A good example of their responsibility was the hideout community. We worked with them to install a 5-acre wetland system. So they have Lake Ariel that comes down that's on septic that has high phosphorus concentrations, and it goes into Roaming Wood Lake. They didn't own Lake Ariel, so they couldn't do anything with that, but they had this 8-acre wetland of just reed canary grass. We did some re-engineering where we created some floodplain cells to treat the water coming from Lake Ariel, and it treated that water before it went in Roaming Wood to remove the phosphorus. So they spent their own money. It was a big community. It was $250,000 for that 5-acre site, but the state then gave them an additional $76,000 because they wanted to do an additional 3 acres of planting. So those types of programs, like the grants, are one way that the state tries to provide information. The other thing is that the state does have water quality criteria, and they try to provide that information on how to let people know, okay, these are issues you need to contend with. And they do have programs available for either education or potential funding to assist with those matters.
Yes.
Yes, I have 2 questions. The first is, how likely is it that we're going to have another algae bloom this year? And secondly, what are the first 3 things we should do to prevent this kind of situation as we face the recreational season this year?
Yeah, I mean, the likelihood of having another algae bloom this year is really going to be predicated on what the weather's like. We've had a pretty warm winter regionally overall, and we'll see if we have another wet spring. If we have another wet spring followed by a really hot August period, I would say there's a decent probability to see similar conditions as last year.
What 3 things should we begin to do as we look to the recreation season?
I would say number 1, I would integrate this monitoring plan that the community can do. So you have kind of a mechanism set up to identify these blooms, to identify conditions that might be setting up for the blooms, to realize how to properly interpret that data and how to communicate that to the community. From a management standpoint, again, it comes down to nutrient control. So potential stripping applications in the lake. If you were to have a really wet spring, if we go into April and May, above average rainfall, and we're seeing reduced clarity in the lake during June sampling, you might strongly want to consider a nutrient stripping application in the lake. And then again, having the means in place to deal with the flumes if they were to occur, potentially adding to your permit things like the peroxide-based algicides.
Yeah, let me dovetail on that, because, I mean, one of the things, when you look at all the models about the Northeast, and Mike showed that slide, the one thing we know for sure is the Northeast will get warmer and wetter. So more water and warmer water temperatures means a higher probability of these cyanobacteria. And, Mike hit it right on the head that, number one, we have to keep an eye on the weather. And it's sort of like a two-level thing. The first level is that direct contact. So those beach mini plants, and we, to be quite blunt, we stole that from New York DEC. They had a program called Beach Restoration Plans that focused on cyanobacteria beaches, and we thought that would be great to offer clients because we're so focused on the watershed and the whole lake, but a lot of people, where they have that direct contact is where you're going to be influenced by cyanobacteria. So having a program where you're monitoring that and you can get a feel for, okay, if it's a wet year, we may not see a bloom until later in the season, or if it's a sunny spring, we know we're going to get our blooms quicker. Having that data will really go a long way in terms of making those management decisions on how to proceed. If you remember one of the earlier slides, you had high phosphorus concentrations in 2018. But 2018 was a relatively cool, wet year. So even the lakes in New Jersey and New York, we had high phosphorus concentrations. But people weren't out recreating as much because there was a lot of rain and it was cooler. Then we got into 2019, wet spring, and then once we started having the sunny weather, that's when those blooms were triggered. So a lot of it is based on the weather. So you need to be flexible enough to keep tabs on what's going on in your system, to be a little proactive on how to deal with it.
I just have a couple of questions too. The monitoring program will give us some numbers that we can then say, oh, the interventions we're doing is working, they're working, or they're not working. We might have to add some chemicals, or we might have to limit, restrict, swimming on certain days, whatever those numbers are telling us. My question is, if say we were to, we install floating islands, or we start using rain barrels more frequently, over more the households, or we put, rocks or something to slow down the water in a drainage source. As we do those things, how quickly would we see changes in the numbers in our monitoring program? Is that something we have to wait, weeks or months or years to see, or is that something we could measure sort of, would we see those impacts quicker, or how quickly would we see them?
Yeah, I just would say quickly, it depends on the scale of how you look at it. Certainly some of those watershed projects, when we implement them, we sample directly before they're constructed. After they're constructed, you can basically sample above and below, and you can kind of see an immediate reduction in nutrients. The benefit to your long-term database is the improvements in the lake over time. You can see that for your longer-term monitoring. Typically, the watershed projects, it's a longer payoff, whereas some of the in-lake management can be a quicker reduction in nutrients.
Yeah, and I can give you two examples of longer term. And so this goes back to having that short-term and long-term plan. The short-term plan is each year, keeping an idea what's going on, looking at the beaches. The long-term is the watershed. And I can give you two examples of the long-term improvements. One is Lake Mohawk in New Jersey. The other is Harvey's Lake in Luzerne County, PA. In both of those instances, it took us about 5 to 12 years until we saw an actual, long-term sustainable improvement. And the reason is it depends on the amount of funding you have to implement these projects. So Harvey's Lake, when they were doing their projects, they were implementing things based on when they got grants. And it took about 5 years until we saw water quality improve. So Harvey's Lake has what's called a TMDL, which is total maximum daily load. It basically says this is your phosphorus load, you have to get down here. So I always say it's like putting your lake on a phosphorus diet. And what we saw is it took about 5 years of that watershed work until we saw the first year that phosphorus concentration was below that threshold. And it's been like that for a good 8-9 years. So they keep implementing projects to stay down there. They're about 80% in compliance with their TMDL. They only have 20% to go. But aside, Monkey Wrench with Harvey's Lake is a very nasty invasive plant. Hydrilla got in there in 2014, and so we've been focusing on dealing with that invasive. The other is Lake Mohawk, private community. They implemented so they're larger and deeper. They have a large injection system for alum that also mixes the water column, keep it well mixed. They installed 12 large sedimentation basins. They have a very aggressive septic management program. They banned the use of phosphorus fertilizers. I mean, it took about, again, 5 to 7 years until we saw, and that lake was, you know, in the 90s when I started working, even before Princeton Hydro, we were called Coastal Environmental Services. Back then, I mean, it was so nasty that they would get green ice. The blue-greens would just be year-round. There was one group of most blue-green algae like warm water, but there was one called Celosphaerium that likes cold weather. So it literally had green ice. So it took about, you know, 2 to 3 years until we stopped seeing the green ice, and then about 5 to 7 where it was acceptable for recreational use. So the watershed stuff, it does take time, and the reason why it takes time is resources. I mean, if you had $200 million and you could implement all these projects at the same time, you may see that improvement within a few years. But usually what it is people get the capital, they implement. And the one other thing I want to mention is any one of these projects, whether it's in-lake or it's watershed-based, requires maintenance. There's always maintenance associated with any of these. So any sort of EMP where it's settling solids, you know, whenever we put, our engineers put one of these programs in place, we always do a maintenance plan. That forebay may need to be cleaned out once a year or maybe once every other year, but there's always maintenance associated with these projects.
Yes.
Who else has a question?
So based on what you just said, and based on the fact that tactically we've just started to try to encourage people to not use phosphorus in their plantings and in their garden, lawn growing purposes, what further can be done when it's hard to monitor people, it's hard to control them, and it's hard to stop them?
Right.
What can we do to encourage people to stop using these nutrient-rich things for the cyanobacteria and the toxins and so forth? Because from what I'm hearing and based on what I've read, not only is the phosphorus bad, but it also has to do with chlorophyll and nitrogen.
Right. Well, so the chlorophyll is the algae. So when we measure chlorophyll in the water, that's telling us how much algae. So the chlorophyll in the watershed won't impact that. Nitrogen is important, but not nearly as important as phosphorus. So, and I was talking about this earlier, when it comes to phosphorus fertilizers, 9 times out of 10, if the grass is not getting enough phosphorus, there's more than likely there's plenty of phosphorus. It's that the pH of the soil is too low. So what I always recommend, if you think you need a phosphorus fertilizer, test your soil, what the pH is. Because 9 times out of 10, if you line your soil, it will bring the pH up, and then it will use all the phosphorus that's already in the soil. So stuff like that. And the thing that, you know, Dave and I were talking about this, you know, an idea really doesn't get into a person's mind until they hear the message 7 times. You know, an idea really doesn't get into someone's mind until they hear it 7 times. An idea really, I do that joke at a class I teach and it goes right over the kids' heads. I'm glad you guys sort of smart. Thank you. So, but stuff like that, though.
Yeah, so I mean, that goes back to the continuing education. I mean, it's difficult to enforce, right, but it's,
But we have seen that education happen. Like we did this, it sounds goofy, but as part of an EPA grant, we actually, for Lake of Patcon, we installed samplers on people's lawns. And one year we allowed people to use phosphorus fertilizers, the next year they used non-phosphorus fertilizers. And so after the first rain event, we collected the samples and did the analysis. And we have like the use of phosphorus fertilizers. Here's the phosphorus being mobilized. Non-phosphorus fertilizers, it's down here. It's like, well, why did you do that? We did that for 2 reasons. It showed people their actions have an impact. And number 2, we could then calculate, well, what if everyone in the watershed used non-phosphorus fertilizers? This is how much phosphorus would be reduced. So stuff like that really goes a long way. We can share that information with the community.
yes.
Our lakes have carp fish, I believe still. The carp eat vegetation, even though it's wetland
Yeah, I mean, that's a good point. I mean, I think there's such an abundance of leafy vegetation in the lake that preferentially going to eat that first as opposed to the roots hanging down. They're not really going to be able to get on top of the island and eat those plants. They will, but they're preferentially going to eat the plants first. And you know, if it were to ever become an issue, you could always cordon those off, like with sediment curtains.
Yeah, and I can chime in on that. So for the hideout community,
Yeah.
we have, there's Deerfield Lake. We have 3 floating wetland islands, very healthy. They stop grass carp for the submerged plants. The grass carp, like Mike said, they're preferential feeders. They like the submerged, leafy, the pond weeds, some of the milfoils. Yes, it's like fresh salad to them. They can eat the roots, but what we've seen is, if you've ever looked underneath the islands, you can't see the roots because they're completely covered with what's called periphyte. That's algae that's attached to the roots. So it's all it's that green goo that's underneath the island that's sucking up the nutrients. The carp do not like to eat algae. So when those roots are covered with that green goo, they leave it alone. And again, Deerfield, we've had 3 islands on there. They stock with grass carp on a routine basis, and we've never had a problem where we've seen it die off. I will tell you though, with the islands, again, maintenance, goosenet. We have to put goose netting on it. And the first set we did in hideout, we had 5 of the large islands. We didn't go out and look at them in the spring. One of them, we got the netting fell down. The geese came on the one island, they ate all the plants, and they actually laid eggs on the island. We had the wildlife expert, add the eggs, remove them, we had to replant, put the netting back up. So again, maintenance and checking it out, making sure in the spring that netting is still up.
At one meeting, I heard about silt. There's so much silt in the bottom of the lake. Some spots are like 4 feet of silt. Is that true?
There's areas where you have that much accumulation, yeah.
Do you recommend removing it?
There's certain areas, where it could be beneficial to do spot dredging. Again, like there's the will it improve navigation, will it reduce plant habitat, yes. So that's a decision as a community we will be considering.
They have said that the rule is that it's problem as to where you're going to put it.
Right, so as part of any dredging operation, you typically test the soils and make sure they're clean. If they are, you could probably place it somewhere on the property that's an upland area, so not a wetland, flat. You can utilize it to dispose of it there.
What happens if you put it on land? Does it
Yeah, it just dries out. And, you would typically go in after the fact and put seed down there and plant it.
I mean, yeah, very frequently we'll use it as sort of non-structural fill, which means you can put it over a ball field, put it over an area, we'll line it, seed it, have some silt fence up. So usually when our engineers are putting permits together for the dredging, they'll also get a permit for the final disposal site. And that's something both Army Corps and DEP will want to see. It's like, well, okay, you're taking 3,000 cubic yards out, where is it going? So you have to have another set of plans showing it's going here. It's an upland area. We'll have silt fence up there for the first growing season. So yeah, there's some manipulation of the material that needs to be dealt with so that it becomes stable. But usually like a ball field or an open field like that is a great way to sort of spread this stuff out.
So it would be somewhere in the local development that you would have to make a spot.
Right, and what really drives the cost of dredging is the round trip to that site. So the closer it is, the better. Number one. Number two is if it's in your property, you won't have to pay someone to, that sort of thing. So we try to get, if a property, if an association has land that they can use, that's the best way to do it.
Is that a normal amount of silt for a lake our size?
I mean, it accumulates over time. It's similar to any lake that's kind of developing in the watershed. You're going to accumulation of silt over time. A lot of lakes in this area are kind of man-made. You also have natural lakes that are getting bigger over time. So yeah, I mean,
Yeah, and I think your rates of sedimentation were higher because think about like 50, 100 years ago when some of these homes were being built. Back then, we didn't know about non-point source pollution. We didn't know, we didn't think about the settling of the solids going in. Now we're a lot more cognizant of it, so now you have the soil district, You know, we try to put the ENS control measures in place. A lot of the homes are already built. So I like to call a lot of times the sediment the sins of the past. It's from all the development that has happened in the past. So it's, you know, the rate of sedimentation going into the future is a lot lower than it is now. We actually did a pretty cool study in Bucks County for Lake Luxembourg, where we had rates from like the 70s to the 80s, the 80s to the 90s, and the 90s to the 2000s. And we really saw in the 80s and 90s when there was a lot of development, where a lot of that farmland was converted into residential. You know, when you compare the amount of silt in this big conservation pool, that's where we saw the highest accumulation of sediment. And that once we got into the 2000s, it went down. It makes sense because that's when rates of development in that part of Pennsylvania went down.
Yeah, that's a good point. I mean, we have residential developments pretty much established, you know, having kind of soil surveys. I think we had 2 different surveys for your community. So in 2014, we computed the rate of sedimentation. I think we estimated at a tenth to 2/10 of a foot a year. So if you think, you know, how many ways it exists.
In 2014, the water and drainage, the shower area. At that time, the sedimentation was 1 to 5 feet a day. It was recommended as beneficial at that time for us to use some spot dredging. But we wasn't going to report. Now, from the report in 1999 to 2014, 15 years, we were saying that the sedimentation increased from 32 to 77% at a rate of 1 to 3 foot, of 1.3 to 3.2 feet per year. So that's down in now in 2014. So the question we're asking is, what would be the results of us, the benefits or the pros and cons of waiting to 2027 to dredge? How much more sedimentation at this rate would we lose that north end of the lake? Would we lose the shoreline? Because it's very difficult to get craft in there right now.
This is Big Bassett?
Yes.
Okay. And the previous report said 1 foot a year?
Yeah, 1.3 to 3.2.
Foot of sediment a year?
Yeah, it was up to 77%.
I mean, I think that
This is what it's all. From 1999 report to 2014 report, 15 years, it was determined the increase in sedimentation 32 to 77%.
So I'm assuming that that percentage is the percentage of the total, it's water and sediment. So what I would recommend is we can take a look at any of the stormwater data that was collected from Tamarack and look at what the TSS concentration is, and then calculate what that pollutant load rate is, at least in the Tamarack area, because that's where a lot of your solids would be coming from. So if we have the concentration from last year's data, the TSS during storm events, we can calculate what that existing sedimentation rate is. I mean, over time, you're right, that percentage will increase. But with selective dredging, what we want to find out is, obviously in the middle of the lake, that rate is a lot lower. The reason being is when the sediment particles come in, the heavier stuff settles out first. So what you tend to see is, near the inlet is where you have the heavier stuff, and there's a higher accumulation. As it goes further out, that's when the finer silts may eventually settle down, and some of the dissolved clays won't ever settle down. But that's what we need to find out, is we can look at last year's data, at least the stormwater data that was collected, and we can get a rate of what it's like now, you know, to see if it has changed. But, you know, in terms of recommending dredging, I mean, ultimately that decision is up to the community. What we're doing is focusing primarily on the algae blooms and the invasive plants, but we could certainly reassess what that rate is. And if it is even higher than it is now, I would be cautious and maybe add a little more. Now, I do know, and this happened, we were looking at the data from when Keith looked at those basins. There was a short period of time where there were high amounts of turbidity coming into the lake, and I think it was 2007? Yeah, around there, because we actually had one of our engineers go up and talk to the trucking facility? Yes. So the reason why there may have been an accelerated period of time is accelerated sedimentation rate. your community contacted us and said, hey, there's a problem. There's a lot of suspended solids coming in. I did a tour with Dave, and then we had our engineer reach out to them. It turned out they had some big sedimentation basins that they weren't maintaining. So we sat down with them, we explained about the maintenance, and then they took care of it and they cleaned it up. So that elevated rate may be that period of time when we saw the high sediments coming in. But what I'd like to do is look at this past year's and see, do we see an elevated rate still, or has it slowed down?
As the sediment still builds up, the water naturally will get shallow.
Right.
So we're going to lose oxygen in that shallow water.
Well, you won't use it.
Is that should also be an increase in the water where it's shallow, the water's going to be cooler?
Yeah, you won't lose oxygen, but what will happen is more sunlight gets in, and you get more plant growth and more algae growth. That's the issue. So that's one of the reasons why we're looking at, selective dredging in that area is, it's not, like Mike mentioned, it is going to remove some nutrients that fuel the algae and the mad algae and the plant growth. It will make less light hit the bottom, which is good, and it will increase that aquatic habitat circulation. So there is value to that. We can certainly look at that data and reassess that.
Sure. Yes.
Does this algae bloom, is this causing effect on any of the fish, the health of the fish, or any other plants that are in the lake? Because this year there seems to be a deterioration of some of the plants on the lily pads on the surface. They seem to be shrinking and dying early. And during the bloom, a number of the bass that we caught in the lake seem to be almost white or gray in color.
I can tell you that relative to the impact of the cyanobacteria on the plants, there's no interaction in terms of the cyanotoxins affecting plants. But there is an interaction between algae and plants relative to competing for sunlight. So if you get a lot of plants early, a lot of times you'll get less algae because there's less space for the algae to bloom and there's less availability of lights and it's harder for them to acquire nutrients. If, say, like this past year, we got all this rain and then sunlight, all this rain and sunlight, you got the blooms, and then you get less plants. Like the Lake of Pacon, where they mechanically weed harvest, in 2019, when the blooms hit, their harvesting was down 75% of what they normally harvest. Like the crews were out there like, we can't find plants. Well, it made sense. The blooms hit, they cover the surface, less sunlight gets down into the water, less plant growth. So there is a competition between the two. Your question on fish is a good one because there's a lot of research being done on how cyanotoxins affect fish. And some studies say there's no effect, some studies say there are effects. What I can say is fish are mobile, so if they're in an area where they detect something bad, they'll swim away. But if they can't swim away, they're getting accosted with that toxin, they can take it in, but they can metabolize it so that it's not like a heavy metal that accumulates in their flesh, that they'll take it in, it can be recorded in their flesh, but it's usually recorded in studies like in a lab where they're putting obscene amounts of the toxin in and see how the fish respond. In a natural setting, most of the time, the fish, will take in that cyanotoxin, but they'll break it down in their physiology. But state federal agencies, when they put their signs up, they still say don't eat the fish, just to be safe. So you're touching on something that there's a lot of research being done and there's no definitive answer. The biology says the fish can break the stuff down, but the regulators are saying if there's a sign up saying beach closure or cyanotoxin advisory, don't eat the fish. I don't think I answered your question, but that's the information that's available.
I have a lot of roots on my land immediately next to the lake, and obviously all the leaves go, everything goes down. So would it be a good idea to remove some of them and replace them with something which was almost like flowers?
I mean, that's a good question. When we get pretty frequently. I mean, my typical recommendation is that the trees and the plants that are growing on the shore are kind of natural feature. And to, obviously maintain the property and stuff, and don't really use the lake. I don't know if I would go through, that cut down the trees and do things.
Yeah, well, I mean, trees are really, I taught in the class of watershed management, I taught quite a bit of the value of trees, that not only are they removing a lot of nutrients, but they help stabilize that shoreline, so you don't have the sloughing in of solids and additional stuff. But they have something called bioretainment, which they take up a lot of the surface runoff, and they either put it into the ground, and then they put it into their biomass, and then it's called evapotranspiration. It goes up into the atmosphere. So a lot of times why flooding occurs is you're not allowing water to get into the ground or up into the atmosphere. And trees really help to do that. There is an issue with leaf litter. And so like Mike said, if you have a lot of deciduous trees, rake that stuff up, mulch it, get it out of there, don't put it into the water. And then one of the BMPs that Mike mentioned, those 3-chambered baffle boxes, what's cool about them, we use them quite a bit at Harvey's Lake. We have at least 4 or 5 of them up there. It has a trash rack on top. So the nice thing about it is the solids go in and they settle in the bottom of the basin. But then it has a trash rack where all the trash and the leaf litter accumulates. And the nice thing about that is the public works crews can then come in and they can just remove that leaf litter. And then it's unhinged, they lift up the hinge and then they can put that backhaul in and suck up the solids. What you don't want is all the leaf litter going in with the solids, because the leaf litter, as it decomposes, nutrients are mobilized. You have this dark box, so you can run out of oxygen. No oxygen means the phosphorus is more mobilized, so now you can make these little pools in these stormwater basins that are now sources of phosphorus that go into your lake. So if you keep the leaf litter out of the solids, with some of those types of BMPs, that's a way of managing.
But your answer is do not remove the trees.
I would not remove trees, and even I know a lot of people want to see their lake view, maybe cutting a portion of the tree, or maybe selectively removing 1 or 2 trees. If you are going to remove a tree, replace it with some other vegetation, like a low shrub, something like that. We didn't touch on it, but geese. I don't know if you have a big goose problem or not, but geese are like cows with feathers. They're not like any other bird. Like you think of a bird eats seeds or caterpillars or they're predators. Geese eat grass. So they're constantly eating, which means they're constantly pooping. So the average goose defecates about 28 times a day. I would have hate to have been the student that figured that out, because I saw a paper on that. They generate more phosphorus than any bird except the cormorant. So they're mobilizing a lot of phosphorus. And that phosphorus goes right into the lake. And I'll use the example of hideout. It's funny, when we walk on the private properties of people who live at the hideout, you have some lots where people have grass growing up to your knees. Wherever they don't have their beach or they have their boat dock, they have the grass going up to your knees. You walk on their lawn and there's no goose poop. You'll literally go right next door and they have the grass right to the edge and there's goose poop all over it. Because geese like to look all the way around. So if you have grass or vegetation as high as their knees, they just won't go over there. They're sort of lazy birds. They're like, I'm not going to go. There's plenty of grass here. Why would I go over there? I can't see any potential predators. So it's funny. We're like doing a tour of this one cove, and it's like you walk wherever there was grass, no poop. Wherever there was grass right to the edge, there was goose poop. So things as simple as that can really go a long way. And again, it's not impeding. If you have your dock and you have your beach and your access, make sure you have that. But any piece of shoreline property that's not being used for that capacity, either plant some native vegetation or at least let it grow up to your knees. Maybe cut it down maybe once or twice. A second time, like at the end of the growing season.
What about the submerged plants? So this was a question from our L meeting a couple of weeks ago. For members that are on the water, are there any negative consequences if they're raking and removing the submerged plants from their shoreline and around their docks?
No, I don't think so.
No.
Yeah, I mean, if they're just removing vegetation around their dock, there's plenty of vegetation out in the open areas. And something we always do with our lake communities, we always try to identify areas that are considered, okay, there's not a lot of homes over there, keep that sort of as a spawning area or let that as a fish refuge. Up near the main inlet where Tamarack comes in, that there is some potential habitat there, but it's filling in so much that I think in the long run, dredging that, letting it a little deeper will actually help in terms of other organisms. So maybe having, along the edges, having the vegetation, but then having that nice open water area for the warm water fish to move in and out of vegetated areas versus those open water areas.
The algae blooms that we're having now, would that cause the fish to lose color? Because most, not the fish that we've been catching are turning like a grayish white color.
Yeah, not that I know of, but I'm certainly going to look into that. Like I said, anything I've seen with impacts of fish on those cyanotoxins mostly has to do with how they assimilate those toxins and whether they build up in their flesh or not. But
We've noticed the fish, the quantity of fish that we're catching in the lakes in big gas has been down.
Mhm.
We had a fishing area in July. This year was the first year in the last 6 or 7 years that we probably saw anything.
Okay.
July. So I don't know if that might have been an indication already that we were starting to be able to see the pollen comes.
Yeah, that might not be necessarily
It's hard to
attributed.
judge that.
Yeah, it could be more of a habitat issue.
Maybe other pathologies.
Yeah, it could be more of a fish community issue.
Yeah, if you have any photos of this, like grayish type fish, or anyone in the community, you send them over to us, and we can take a look at it. And we certainly have some
Jeff
fish.
does more fishing.
Okay.
I noticed it on not just one species of fish, but there's 5 of them.
Okay.
The black crappie,
Yep.
the pickerel, perch, and bass, and a few Peruvian notebooks too. And what some of the other folks said was like the color was gone.
Okay.
That's my observation.
If you have photos, if you could send them to us, and appreciate it.
If it happens this
Okay.
season, I'll, yeah.
Absolutely, and we'll look, we'll do a literature search and look into it. I know relative to cyanotoxins, I haven't heard of them affecting the pigmentation of fish.
It may have not, it may have just been some
Yeah.
other things, oxygen or whatever,
Yeah,
but it seemed to all,
occur around the
and
same
it all
time.
came, yeah,
Yeah,
it's
okay.
fine.
Yeah, no, we'll take a look at
Yeah, I mean, that's a good observation. I mean, it's all different types of species. Perhaps it's something that's systemic, so, yeah, we'll look into it.